I have been lying to you. For 7 videos now, I have used the phrase the speed of light as if I know what it means, as if anyone does. And I need to correct that, because the name itself, the speed of light, is one of the most misleading phrases in all of science. It has confused generations of students, spawned decades of bad science fiction, and hidden what might be the most disturbing truth about the universe we live in. The speed of light is not about light. Let me say that again because I think it is the single most important sentence in this entire video. The speed of light is not about light. Light happens to travel at this speed, yes, 299,792 kilometers per second exactly. But so does gravity, so do gravitational waves, so does every massless particle in the universe. If you removed every photon from existence, this speed would still be there, built into the geometry of space-time itself. The correct name for it is the speed of causality. It is the maximum rate at which one event can influence another. The fastest that a cause can produce an effect. The fastest that any information in any form, can travel from one point in the universe to another. Light does not define this speed. Light obeys it, just like everything else. And I think the name matters. When you call it the speed of light, people instinctively think of it as a property of light, like its color or its wavelength. They think of it as a speed limit on a highway, something that exists because someone decided it should, something that better technology might eventually break. That intuition is completely wrong. This is not an engineering problem. There is no engine you can build, no fuel you can burn, no technology you can invent that will let you transmit information faster than see. And the reason is not that we are not clever enough. The reason is that space-time itself does not contain paths that allow it. Let me show you what I mean, starting with something I covered in the first video of this series. If the sun disappeared right now, vanished, mass and all, Earth would continue orbiting normally for 8 minutes and 20 seconds. Not because information is slow, but because that is how long it takes for a change in the gravitational field to propagate across 150 million kilometers at the speed of causality. For 8 minutes and 20 seconds, we would orbit a star that does not exist. The sunlight on your face would be light from a dead star. The gravity keeping you in orbit would be the ghost of a mass that is no longer there. Isaac Newton thought gravity was instantaneous. In his framework, if the sun vanished, Earth would immediately fly off in a straight line. But Einstein showed in 1915 that gravity propagates at exactly c. It is not a force that reaches across space. It is a distortion in the fabric of space-time, and that distortion spreads outward at the speed of causality, like a ripple in a pond. In 2015, LIGO detected those ripples directly for the first time, gravitational waves from 2 black holes merging 1.3 billion light-years away. The waves arrived at exactly the speed of light, not because they are light, because they are information. And information has a speed limit. I want to pause here, because I think this realization is where most people's understanding breaks. They accept that light has a speed, but they think gravity might be different, or that there might be a loophole somewhere. There is not. Every experiment ever conducted, every observation ever made, every theory that has survived contact with reality confirms the same thing. C is universal. It applies to everything. Not because physics has a rule book, because space-time has a geometry, and that geometry has a maximum propagation speed, the same way a drum has a maximum speed of sound. Now, here is where it gets strange, because there are things in the universe that appear to move faster than light, and I need to explain each one because the pattern they reveal is more interesting than any individual example. The first and most dramatic is the expansion of the universe itself. Right now, galaxies beyond a certain distance from us are receding faster than the speed of light. Not slightly faster, some are receding at 2 or 3 times c. This is not a theoretical prediction, it is a measured fact. We can see these galaxies. Their ancient light reached us before they crossed the speed of light threshold, but the light they emit right now, today, will never reach us. They are moving away faster than their own light can close the gap. Does this violate relativity? No, and the reason is one of the most counterintuitive ideas in cosmology. The galaxies are not moving through space faster than light. Space itself is expanding, carrying the galaxies with it. There is a critical distinction here. Relativity says nothing can move through space faster than c. It says nothing about space itself. Space can expand at any rate it wants, and it does. I covered the observable universe in the second video of this series, but I did not fully explore what expansion means for the boundaries of what we can know. I will come back to that. It is the most disturbing part of this video, and I want to build to it properly. The second example is cosmic inflation. In the first fraction of a second after the Big Bang, and I mean a truly unimaginable fraction, roughly 10 to the minus 36 seconds, space expanded by a factor of at least 10 to the 26. That is not a typo. The observable universe went from smaller than a proton to larger than a grapefruit in less time than it takes light to cross a single atom. The expansion rate during inflation was vastly faster than c. And once again, it did not violate relativity because it was space expanding, not objects moving through space. I talked about inflation in my third video about what came before the Big Bang, but I did not say what I actually think about it at the time, and I want to say it now. Inflation is simultaneously the most successful and the most suspicious idea in modern cosmology. It solves the horizon problem, why the cosmic microwave background is the same temperature in every direction, and it solves the flatness problem, why the universe's geometry is so close to perfectly flat. But it solves them by invoking a mechanism that operated for an inconceivably brief time, at inconceivably high energy, and then stopped. We have no direct evidence that inflation happened. We have only the consequences that look exactly like what inflation would produce. I believe it probably happened, but I hold that belief more loosely than almost anything else in this series. The third example is one that actually fooled astronomers for years. Some quasars, the violently active cores of distant galaxies powered by supermassive black holes, appeared to emit jets of material moving faster than light. This is called superluminal motion, and when it was first confirmed in the early 1970s, it caused a genuine crisis. How could matter travel faster than c? The answer is that it cannot and it does not. Superluminal motion is a geometric illusion. When a jet of plasma is moving at 99% the speed of light and is aimed nearly but not exactly at us, the combination of its high speed and its angle creates an optical illusion where the apparent transverse velocity on the sky exceeds c. The jet is not actually covering more distance per unit time than light would. It is chasing its own light, compressing the arrival times of its photons, making it look faster than it is. NASA has directly imaged these jets and confirmed the geometry. I find it fascinating that the universe can produce an illusion of faster-than-light travel purely through geometry. It is as if the cosmos is showing you what breaking the speed limit would look like, while making sure it never actually happens. The fourth example is Cherenkov radiation, and this one is actually my favorite because it is the closest thing to genuinely exceeding the speed of light that actually occurs. When a charged particle, say a high-energy electron, enters a medium like water, the speed of light in that medium is slower than c. In water, light travels at about 75% of its vacuum speed. But the electron does not care about the medium's speed of light. If it has enough energy, it enters the water traveling faster than light travels in water. The result is an electromagnetic shock wave, the optical equivalent of a sonic boom, a cone of blue light radiating from the particle. This is Cherenkov radiation, and you can see it with your own eyes in nuclear reactor cooling pools. The water glows an eerie, beautiful blue. The particle is genuinely exceeding the local speed of light, but it is not exceeding c, the vacuum speed. The speed of causality remains unbroken. The loophole exists only because light slows down in a medium. The particle does not speed up beyond the fundamental limit. There is a fifth category that I want to mention briefly. In certain optical experiments, the phase velocity of light can exceed c. This is the speed at which the crests of a wave move, and it can be faster than the vacuum speed of light. But phase velocity does not carry information. You cannot encode a signal in the phase of a wave and transmit it faster than c. The distinction between phase velocity and group velocity, the speed at which the envelope of a wave packet moves, which does carry information, is the key. Group velocity never exceeds c in any known medium. And then there is quantum entanglement. I want to address this because most people who have heard the phrase faster than light associated with quantum mechanics. When two particles are entangled and you measure one, the other's state is determined instantaneously, regardless of the distance between them. Einstein called this spooky action at a distance, and he hated it. Veritasium made an excellent video recently about the Einstein-Bohr debate and Bell's theorem that goes deep into the quantum mechanics, and I recommend it. What I want to say instead is what I think it means for the question this video is asking. Quantum entanglement is real. The correlation is instantaneous. But, and this is the critical word, you cannot use it to send a message. The result of each individual measurement is random. It is only when you compare the two measurements afterward, using a classical communication channel that is limited to c, that the correlation becomes apparent. The universe allows instantaneous correlation, but forbids instantaneous communication. The pattern holds. And this is the pattern I want you to see. I have now listed 6 phenomena that appear to break the speed of light, and every single one obeys the same rule. No information transmitted faster than c. The universe expands faster than c, but no signal crosses the expanding gap. Inflation was faster than c, but no information was transmitted through the inflating space. Superluminal jets appear faster, but it is a geometric illusion. Cherenkov radiation exceeds the local speed of light, but not the vacuum speed. Phase velocity exceeds c, but carries no information. Entanglement correlates instantly, but transmits no message. I do not think this is a coincidence. I think the universe is telling us something fundamental about its own architecture. The speed of causality is not a rule imposed from outside. It is not a law that the universe follows. It is a description of the universe's structure. Space-time is built in such a way that cause and effect can propagate at a maximum rate of c, and everything is downstream of that fact.
But where does c come from? This is a question that bothers me, and I think it should bother you too. In 1865, James Clerk Maxwell unified electricity and magnetism into a single set of equations. When he solved those equations for a wave propagating through empty space, the speed that fell out was exactly c. He did not put the speed of light into his equations, it emerged. He calculated it from two measurable properties of empty space, the permittivity and the permeability of the vacuum. In other words, the speed of light is determined by the electrical and magnetic properties of nothing. The speed of causality is a property of the void. Einstein took this further in 1905. He showed that if c is the same for every observer, regardless of their motion, then time itself must be flexible. Clocks slow down, lengths contract. The energy required to accelerate further climbs toward infinity, and the universe rearranges its geometry to ensure that no one, anywhere, ever measures a different value for c. I covered the consequences of this in my last video on time travel, but I did not say what I think about the underlying reason, because at the time I did not have the framing. Here is what I think now. I do not believe c is a speed limit in the way that phrase is usually meant. A speed limit is something external, something imposed. I think c is a consequence, a structural feature of space-time geometry. The universe is not obeying a rule. The universe is shaped in a way that makes c the maximum propagation speed, the same way a sphere is shaped in a way that makes pi the ratio of circumference to diameter.
You do not ask why a sphere obeys pi. It is not obeying anything. It is just being a sphere. Space-time is not obeying c. It is just being space-time. Now let me explain why I think this is the most important speed in the universe, by showing you its most terrifying consequence.
Hello out there!
The observable universe is 93 billion light-years in diameter. I covered this in my second video. But here is what I did not say then, because I did not fully understand it myself until I started working on this video. Because the universe is expanding, and expanding faster than c at large distances, there is a boundary around us called the cosmic event horizon. It is not a physical wall, it is a mathematical surface. Beyond that surface, the expansion of space is fast enough that light emitted today from those regions will never reach us. Not in a billion years, not in a trillion, not ever. Those regions are causally disconnected from us permanently. And that boundary is getting closer. Every day, more galaxies cross the cosmic event horizon and become permanently unreachable. The light they emit after that moment will redshift toward infinity and fade to nothing. From our perspective, they will slow, redden, and freeze, exactly like an object falling into a black hole. The parallel is not a metaphor, it is the same physics. An event horizon is an event horizon, whether it is around a black hole or around the observable universe. I want you to sit with what that means. Right now, you can look through a telescope and see galaxies that are already beyond the cosmic event horizon. You can photograph them. You can measure their spectra.
But you are seeing them as they were billions of years ago, when their light could still reach us. The galaxies you see are ghosts. They exist, but they are already gone from our causal universe. No signal we send will ever reach them. No signal they send will ever reach us. We can see that they are there. They will never know we existed. I find this the loneliest idea in all of physics. Not the heat death of the universe, which at least takes trillions of years. Not the inside of a black hole, which at least is dramatic. This is quiet. This is slow. Every day the observable universe gets a little smaller in terms of what we can ever hope to contact. Every day more of reality becomes permanently invisible. And there is nothing, no technology, no physics, no miracle that can change it. Because it is not a problem of distance, it is a problem of speed. The speed of causality means that the expanding universe is slowly and permanently disconnecting itself from itself. If the universe is infinite, and the evidence from Planck satellite data suggests it is very close to flat and possibly infinite, then what we can see is an infinitesimally small fraction of what exists, and most of what exists is already unreachable. We live on a tiny island of causality in an ocean of unreachable reality, and the island is shrinking. I think about this more than I probably should. There might be civilizations out there, billions of them, that we will never detect, never contact, never know about. Not because they are too far away in a practical sense, because the geometry of spacetime forbids it. The speed of causality is not just a speed limit, it is a relationship limit. It defines the maximum size of your possible community, and that community is finite and getting smaller. Let me bring this back to where I started. I have been calling it the speed of light for 7 videos because that is what everyone calls it, and changing the language mid-series would be confusing. But the honest name is the speed of causality. It is not about photons, it is about the structure of space-time. It is the speed at which reality updates itself, the speed at which one part of the universe can know what is happening in another part. It is the bandwidth of the cosmos. And the most important thing about it is not that nothing can go faster. The most important thing is what that means for us. It means the universe is partitioned. It means there are regions of reality that are real but unreachable. It means the cosmos is not one connected thing. It is a vast collection of causally isolated islands, each one able to see the fading light of the others, but unable to send a reply. The speed of light is not a lie in the mathematical sense. 299,792 kilometers per second, every time, everywhere, without exception. But the name is a lie, because it suggests the speed is about light, and it is about everything. It is the deepest speed in the universe, and it is the reason the universe is, in the end, a very quiet place. Next time, we confront that silence directly. There are 2 trillion galaxies in the observable universe alone. The probability that we are the only intelligence seems absurdly small. And yet, nothing. No signals, no visitors, no evidence that anyone else has ever existed. The numbers say the universe should be teeming. The evidence says it is empty. Something does not add up, and the possible answers are terrifying. That is the Fermi paradox, and what we discussed today, the speed of causality and the shrinking horizon of contact, might be part of the answer.